Probability of an invisible deck. So what are the chances that the card that you named is the card reversed in the pack? First of all, assumptions. All good maths is based on assumptions, so here's ours. The first assumption is that we're doing this for real and it's not just a magic trick. If it's a magic trick, the probability of success should be certain, unless you screw up. Secondly, we're assuming that the card reversed in the pack was chosen at random. You're not just constantly turning over your favorite card. Lastly, we're assuming that the card that is named is also chosen at random, and that the person isn't just naming the only card that they know the name of. First, we'll start with the card that we reverse in the pack, our prediction. The probability of us drawing out any particular card is 1 in 52. For the sake of argument, let's say that card is the Ace of Spades. In maths lingo, we write that down as this, which reads as probability of choosing the Ace of Spades is 1 in 52. With the invisible pack, the spectators are also going to choose a card. Now, an invisible pack is still a pack of cards. It's still got 52 cards in it, although you can't see them. Therefore, the probabilities are still the same, so the probability of choosing the Ace of Spades is still 1 in 52. To differentiate between the two packs, we'll write the invisible Ace of Spades down as probability IAS, which is still 1 in 52. Now this bit's important. The two choices of cards from the two different packs are statistically independent. This means that your choice of card doesn't affect which card the spectators name. It's a bit like tossing a coin. If you toss a coin once and you get heads, it doesn't affect the outcome of the next toss. So what's the chances of both the cards being the Ace of Spades? Well, that's written down as PAS intersection IAS, which for two statistically independent events, we just take the two probabilities and multiply them together. So 1 in 52 times 1 in 52 is 1 in 2,704. Pretty slim chances. But, here's the big but. There's more. You see, that's the chances of both the cards being the Ace of Spades. But what if they were the 2 of Spades, or the 3 of Spades, or the 4? You see, we're not interested in the probability of 2 Ace of Spades, but the probability of 2 matching cards. Now to simplify it a bit, we're going to look at a coin toss. The chances of tossing a coin and getting a head or a tail are both a half. So we toss our coin, we can get a head or a tail, 50-50 chance. It's a bit like choosing our prediction card with the card trick. We'll toss the coin again. This is a bit like picking the invisible card from the invisible pack. Again, the chance of each is a half, and so we'll get 4 possible outcomes. Now the chances of us getting 2 heads is a quarter. 1 out of the 4 possible paths gives us 2 heads. You can work that out by timesing a half times a half to give you a quarter for 2 heads. But if we're looking for 2 matching values, we could also get 2 tails. The probability of getting 2 tails is also 1 in 4. This means the chances of getting 2 matching values, though, is 2 in 4, or a half. Back to the cards. Using what we learnt from the coins, this means that the probability of actually getting 2 matching cards is the probability of the Ace of Spades and the invisible Ace of Spades, or the probability of getting 2 of Spades and the invisible 2 of Spades, or the probability of getting 3 of Spades and the invisible 3 of Spades, right the way through the pack. When we do all the maths working out, you find in the end that works out as 1 in 2,704 times 52, which is the probability of an invisible deck, which is 1 in 52. Well, thank you for watching. If you've still got any questions, I'm going to go a little bit more in depth on it. Otherwise, have fun with it. So, not convinced. Well, the first choice, a prediction. In order to predict anything, you have to make a choice from the set of possible outcomes. In this case, the set of possible outcomes are the values of the 52 cards. You have to choose one of those, otherwise the probability of matching is 0. If you choose a master card, nobody's going to name it. When you have 52 different values to choose from, the probability of choosing any one of those values is, if it's a random and equal distribution of probability, then it's 1 in 52. But I know I can hear you saying, but what if I always choose the same card? Then the probability of me choosing, say, the Ace of Spades will be 1. Well, have no fear. because the probability of choosing ace of spades and getting an invisible ace of spades, in this case, is going to be 1 times 1 in 52, which is still 1 in 52. So whether your choice is random, or you always choose the same card, you still have the same odds of getting a matching pair. But one card is chosen first. Doesn't that affect the statistics or the probabilities? Well, true, one is chosen first, but the two events are statistically independent, so it makes no difference. In maths lingo, it's the probability of choosing the ace of spades given that the ace of spades has already been chosen. Here's the math behind it. If you look at the third line down, you'll see how it goes probability of the invisible ace of spades times by the probability of ace of spades divided by the probability of the ace of spades. Those two PASs will cancel each other out, and that will just leave us with the probability of getting an invisible ace of spades. So it's really unaffected by the previous choice. Finally, we'll take another look at that simplified coin toss model. The probability of two matching values was 2 in 4 or a half. But what if we chose a head as a prediction and we were tossing the coin again to see if we got a matching value? Well, we'll get rid of everything there to give us a head as a prediction. We toss the coin again, and you see the probability of getting a head to match the first one is still a half. So any way you look at it, the odds are the same. Maths is a bit clever like that. Well, thank you for watching. I've been Paul Brown, and I hope you found it interesting, and all the best.